Previous videos, we have discussed how to name positive complex, negative complex, and neutral complex, right? So in this video, we are going to discuss about how to name complex having two coordinate ions. Two coordinate ion means like both positive and negative part will be like complexes. Okay, look at these examples. As you can see, it has two parts, right? So obviously the first part is going to be positive and the second part is going to be negative. So how to name such complexes? Okay, it's very easy. So what to do? So the first thing is whatever is given in the first part, the first square bracket, okay, treat it as a positive complex. So you should follow the rules for positive complex while naming that. The second one, the second part is negative, so treat as a negative complex. Okay, then follow the rules. So here is like positive complex mean we use a metal name as such. So here we use silver, right? Here this is a negative complex. Negative complex we use metal with ATE, so it's argentate. Argentate. Okay, that's it. Now, the important thing is in such examples, only one ligand will be negative. Okay, one type of ligand will be negative. Both won't be negative. Okay, so here you can see here the ammonia is neutral, whereas cyanide is negative. So what is the charge of cyanide? We know cyanide is Cn minus. So there are two Cn, so minus 2. So there is only, from the ligand part, there is only cyanide is having charge minus 2. Now the whole new complex is 0, right? The whole complex charge is 0, no charge. So we have to balance this minus 2 by plus 2. Then only the complex will be neutral, right? So now the plus 2 has to distribute the plus 2 is actually the contribution from the metal, right? Okay, so what to do? You divide this plus 2 charge equally to both metals. So both of them will give plus 1 each. Okay, so what to do? How to assign charges? Just look at which ligand has a charge. So basically here cyanide has charge which is minus 2. That has to be balanced by plus 2. The plus 2 is it's a contribution from the metals. There are two metals, okay, from either side. So just distribute equally the plus 2 charge. So plus 1 go to this first AG, plus 1 go to the second AG. Okay, so how to name this? So treat the first part as positive. Okay, so it will be 2 ammonia, right? So diamine. It's a positive complex. So name of metal as such, silver. Okay, what is the charge? 1. How we got 1? Because cyanide was minus 2. Okay, balancing should be plus 2. That we distribute equally to the two metals, plus 1 each. So silver 1. Okay, now there's a negative complex. So this is only left. So there are two always ligands first. So 2 cyanide. So it's a negative ligand. So dicyanide. Okay, now this is negative. So metal is being part of negative complex. So with ATE. So argentate. What is the charge? Always metal, you have to represent the charge in Roman letters. So argentate 1. So diamine silver 1, dicyanide argentate 1. That's it. Okay, we'll see more examples. The first one already we did. Now the second one. So you have cis cyanide here. Okay, cis cyanide. So cis cyanide, one cyanide is Cn minus. So minus 6 is the total charge that has to be balanced by plus 6. So this plus 6 is coming from two metals. Okay, here you have two metals, chromium and cobalt. So distribute that plus 6 charge equally. So the cobalt will get plus 3, chromium will get plus 3. That's it. Okay, so we name it. So treat the first part as positive. So cis ammonia is there. So hexaamine double M. Hexaamine cobalt 3 because it's positive, cobalt 3. Okay, now the negative complex. It's cyanide, it's a negative ligand. So hexacyanido, it's metal with ATE, it's negative. So chromate 3. Chromate 3. That's it. Okay, now look at the third one. Same thing, right? So only the metal is being interchanged. So here it will be like again its cyanide minus its balancing plus its that will distribute equally. So plus 3 each. Okay. So hexamine chromium 3 hexacyanide hexacyanide it's 80, so cobaltate cobalt with 80 cobaltate 3. Okay, so can you try the next one? So like you try the next two. Okay, so I'll post the answers in the descriptive box. Okay, so you can check your answers. Hope it's clear. It's very simple. Like whenever you're getting a complex like this, remember the first part will be positive, treat it as positive, second is negative. So follow the rules for positive and negative. So the first one metal will be as such, second will be like with 80. Okay, then look at the charge of the ligand. Okay, whatever the total charge is coming, okay, that will be balanced by the metal part that distribute the charge equally among the metals. Okay, hope it's clear. So we'll be coming with more videos. Please subscribe and share and support. Okay, thank you so much.